Today we're going to talk more about fraction addition, and in class on the Zoom call you'll get a chance to enjoy a number story, or I should say a fraction number story called Queen Arlene's Dilemma. But to warm up our brains for that, I want you to try out this do now. So it says label the pieces in these drawings that sum up to one whole. Then write a fraction addition equation. So I did a pretty simple example right here. The circle was my whole, and it was split like this. Then I would know, since it's split into 4 equal pieces, each of those pieces was a fourth, and my equation to sum up to one whole was 1/4 plus 1/4 plus 1/4 plus 1/4 equals a whole. Pause the video, and I want you to go ahead and try the next 3 on your own. They are a little trickier, as you can see, because the parts aren't all equal. Play back the video when you're ready to go over the answers. Looking at this first shape, I could see this big piece here relative to the whole is a half of the whole. But then these smaller pieces, those are half of a half, or a fourth, right? It would take 4 of those smaller pieces to fit in a whole. So now I can come up with the equation 1/2 plus 1/4 plus 1 more fourth equals a whole. And in my head I can check that too, because I know 1/4 plus 1/4 is 2/4, and a half is also equal to 2/4, and 2/4 plus 2 more fourths would be 4/4, also known as a whole. So that was my quick math to check using some common denominators there. You could simply kind of look right away and make a half into 2/4, and you'd check that you would end up with then adding them all together, 4 out of 4, or a whole. Number 2. So again, this big piece here is just half of a whole. Similar to problem number 1, this medium-sized piece is a quarter. It would take 4 of those to fit in a whole. And then up here, the smallest little triangle is half of a quarter, also known as 1/8. It would take 8 of these triangle pieces to fit into the whole thing. So looking at what I've written, I can see that a half plus a fourth plus 1/8 plus 1/8 will give me a whole this time. And again, you could check that by converting these all to a denominator of 8, and you'll see that they sum up to 8 out of 8, also known as a whole. Okay, let's try this last one. Again, my biggest piece here is a half. And then over here, this is kind of tricky. I'm going to have to use some symmetry to help me understand how many pieces this is. So if I were to split this into equal pieces, right, it would go like that. And then I have, oh, okay, so I had 3 equal pieces in a half. That means that this one, because in the whole, then there'd be 6. So that little tiny one there has to be 1/6. And now I know here that this is 2/6, but 2/6 is also the same as 1/3. Or maybe you could see right away that this middle-sized piece, it would take 3 of them to fill up the whole. So the equation I'll come up with here is a half plus a 6 plus a third equals a whole. Really neat how you can, now we're ending up with equations with different denominators, right, and that we hadn't had before, but you're getting those from the visual model to make sure they add up to the whole. So let's go ahead and look at your home link for this lesson. and just analyze it a little bit together, and then you're going to do the rest of the home link on your own. Fraction error finder, it's called. So already you know it's going to show you some mistakes. I won't make any mistakes on purpose, but when you go to look at the home link later, you will see some mistakes on there on purpose because it's your job to find them. Consider this problem. A king owns land outside of his castle. He has partitioned the land to give as gifts to his 5 sons. And this is what it looks like, right? What fraction of the land did the king give to each of his sons? So we're going to look at this the real way together. I want you to pause the video and write out for each son what fraction you see. So I'll do the easy one for you. Andy, relative to the whole, has a half of the land. Okay, go ahead and pause the video and try to find Bill, Carl, Dirk, and Evan. Okay, so you may have noticed, right, that Dirk and Evan each had half of the half. So they had a quarter each. And similarly, Bill and Carl, even though the shape is different, they too, if you had to fit this triangle piece into the hole, you would need, oops, I did that wrong. I'm sorry. They didn't have a half. They had an eighth. Sorry, it would take 8 of their pieces to fit in there. So I lied. I said I wasn't going to make errors, and I made one. Hopefully you caught that for me already. So similarly with Bill and Carl, you'd have to have 8 of these triangles to fit into the hole. So they each got 1/8 too. And I'm just going to check my work down here, and this can help you too later on your home link to make sure you check it and prove correctly what you've done. So what I'm suggesting is that 1/2 plus 1/8 plus 1/8 plus 1/8 plus 1/8. I'm saying that that's supposed to equal 1 whole. Well, I want to prove this. So I'm going to add all of these together to get 4/8. Do you agree with me so far? And so now I'd have 1/2 plus 4/8, but instead of a half, I'm going to use the power of the equivalent fractions rule. And I'll make this multiply by 4 to get 8 in the denominator. Whatever I multiply in the denominator, I also multiply in the numerator. So you know 1/2 is the same as 4/8. Okay, now this looks like an equation or expression I can add. 4/8 plus 4/8 is 8/8, also known as 1 whole. So we can see that our divisions here make sense. In the home link, they're going to throw some mistakes at you, and you have to prove that if you tried to add it up the way they did it, it's not going to equal the whole. You'll see, is it going to be more than a whole? Is it going to be less than a whole? Use your knowledge of fractions to prove that.